So in order to understand 6 BPE, so first you have to know the basic component in the MPLS VPN cloud. So for 6 BPE technology, first of all, you should know what is BRF. Second is route distinguisher. Third one is route target. Fourth is of course VPN address family concept. So if you see the architecture of this layer 3 VPN, so I have, this is my router, which is provider edge router. There is P router, and then I have provider edge 2. So now in order to give the service to various customer, the edge router is dividing its routing table into VRF. So virtual routing forwarding is the independent routing table. So VRF A, and let's say I'm creating VRF B. So VRF A is connecting customer 1, and VRF B is connecting your customer edge 2. Now you're doing the separation of this routing table, but behind the scene, for a control plane perspective, you have only single chassis in this router. So there is might be the case, for example, if customer 1 is using 2001::1, so your customer edge 2 can also use the same addressing scheme. So even though they are connected with the separate VRF table. So how this router will identify that the uniqueness of this route. So in order to identify or make the prefix unique, this is using the concept which is known as route distinguisher. So this value you can think like route distinguisher is like VLAN.1Q tag. So route distinguisher is consisting 64-bit information. And the format of route distinguishers you can write in AS number versus local number, and also in IP and local number. So although if you say on VRF A, your suppose AS number is 14, so say VRF A, your RD is 14:1. So on VRF B, you need unique RD value 14:2. So same thing you can do on provider edge. So this is my VRF A or VPN A. This one is the VRF B. Now on VRF A, you can set the route distinguisher something different value like 14:3. But in this case, if you're using the different RD value, so that means you're consuming the CPU resource and database in this local router. So the idea is just keep the same value, although it is not required. So 14:1, and on VRFB you can set 14:2. So root distinguisher is required. So when the customer is sending this prefix to VRFA, so this edge router is going to be attach this RD flag. And once it is attaching this RD flag 14:1, the prefix is now becoming VPN version 6. And if it is a V4 traffic, so VPN version 4. So root distinguisher is only going to be identify the root uniqueness. It will not give you the identification that this prefix is belongs to which VPN. This is belongs to VPN A or VPN B. So in order to identify the VPN membership, the second attribute is used, which is known as a root target. Now root target is using the export import logic. Export and import logic. So this is also 64-bit in length. That is known as the extended community attribute. And the format is similar with RD. So you can set with AS local number and IP and local number. So now suppose your BRFA is setting the root target export value is, for example, 14:100. So if this VRFA want to install this information in the local VRF table, so it must import this attribute 14:100. So whatever the provider edge is going to be export, the other edge need to be import in order to download the information in the local table. Same concept over here. So if this is exporting, if VRFA is exporting value with 14:101, so this need to be import 14:101. There is a default root filtering if you're not going to be match this export and import variables. So once all components is in place, so the first component you need within this cloud is you need LDP. Then of course you need any IGP protocol. And then between the edge to edge routers, you need MPI BGP session. MPI BGP sessions. So in order to see this, the quick demonstration that how we can send traffic by using this, the layer 3 VPN.